All right, number 62. Three objects connected by strings as shown in the diagram. Okay, the pulley's frictionless. So we got 5 kilogram, 4 kilogram, 3 kilogram. So let's just label these guys. Let's call this guy, the 5 kilogram guy will be M1. The 4 kilogram guy will be M2. The 3 kilogram guy will be M3. Now, here's what they want. They want us to find the acceleration of each object. Doesn't that kind of make it sound as if like each object has its own acceleration? A little bit. Guess what? All three objects are connected by a string, so what must be true about their accelerations? They're the same. All three of these guys have the same acceleration. All right, so let's focus on A first. Find the acceleration of all three. All three of them have the same acceleration. Now, here's a little trick, and you don't have to do it this way. You could solve this by doing 3 free body diagrams. You know, do a free body diagram for the 5 kilogram, a free body diagram for this guy, and a free body diagram for that guy. So if you do 3 free body diagrams, then how many times do you have to sum the forces? 3 times. And it's solvable that way. You know, maybe at the end of the video I'll show you how you could do it. But look, what I like to do for a problem like this is simplify it. So when I do my free body diagram, I'm gonna take M2 and M3 and just make it one mass, right? So let's do the free body diagram over here. So here's the pulley. Here's M1, right? Or M1's a circle, sorry. Circle. No, you know what? That'll look like the pulley. Whatever. M1, that's this guy, the 5 kilogram guy. And then on the other side of the pulley, we're going to have this dude, which is M2. Now, what's M2 going to be equal to? 7. That's going to be 7 kilograms because I just combined them, right? Just combine the 4 and the 3. Oh, and I should mention here, how many tensions do we have in the original diagram? 2. We have, because there's 2 ropes, right? We have the rope that runs over the pulley. So let's call that T1. The rope that runs over the pulley will be tension 1. And then the rope in between the 4 kilogram and the 3 kilogram, the tension in there, we'll call that tension 2. Okay? So what tension is going to be on this simplified free body diagram? Tension 1. The rope that goes over the pulley. So T1, and then we have M1G down. Then over here we have T1 up, and then down. Look, I'm just going to plug in. So what is this mass here really? It's 7 kilograms. It's the 4 plus the 3. So let's just, we'll call that M2G. But look, for this simplification, M2, it's not this guy. It's the 7 kilogram. Okay, because I've simplified the problem. All right, let's talk about sign convention. So what's the sign convention for pulleys? Well, you want the direction of the acceleration to be positive. So which way is this 5 kilogram guy, the guy on the left, which way is he going to accelerate? Up. So let's say that up is plus, down is minus. That's our sign convention. Now, what happens to that sign convention? It goes around the pulley. So over here, down is plus. Okay? The sign convention wraps the pulley because, you can't have a positive acceleration on one side of the pulley and a negative acceleration on the other. Okay, so any questions up to this point? That's the free body diagram for the simplified situation. Okay, so now what we're going to do is we're going to sum the forces. So for M1, we sum forces. For M2, we sum forces. Okay, so what are the forces on M1? We have T1 up and M1G down. And actually, we know what M1G is. M1G is 49. Should we just plug that in? Right? 5 times 9.8. So let's just plug that in. So M1G here is 49 newtons, And then this mg over here is 68.6. Okay, so this is T1 minus 49. And then what is the sum of the forces always equal? MA. But don't just say MA, it's M1A. So we just wrote an equation. All right, now we go to M2, which is the 7 kilogram guy that we simplified. And then we're going to have M2G down, which is 68.6. Does everybody see where I got these numbers? Just mg, 7 times 9.8 is 68.6. Minus T1 equals M2A, where that M2 is 7. Okay? So now we have two equations, two unknowns. Right? This is basic algebra now. So we're going to take this equation, solve it for T1. T1 is going to be equal to M1A plus 49. And then take this equation, solve it for T1. That's going to be 68.6 minus M2A. So now if the T's are equal, then the right side of the equation is equal. So we got M1A plus 49 equals 68.6 minus M2A, and then solve for A. So A is going to be 68.6 minus 49 over M1 plus M2. So that is 19.6 divided by 12, which gives 1.63 repeating meter per second squared. So that's the acceleration of all three objects. All three objects have the same acceleration. Okay? Any questions at all with that? Okay, now we can easily find T1. How could we find T1? The tension in the rope that runs over the pulley. Well, you can either plug into this equation or you can plug into this equation. Either one works. Which one looks easier? I don't know. Let's take the top one here. So T1 is going to be M1A, so M1 is 5, so I'm plugging into this equation right here. So it's going to be 5 kilograms times A, which is 1.63 repeating, plus 49. So then T1 comes out as 57.2 newtons. Okay? So there's only one thing left to find. What's the one thing left to find? T2. The tension in the rope connecting the 4 kilogram and the 3 kilogram bucket. Okay, so I'm gonna clear the page. Can I clear it? Okay, so now we're back to the original problem. So what did we find out already? We found out that the acceleration of all three of these is 1.63. So that's going to be really helpful. Now, we're trying to find the tension in that rope right there. So how are we going to do this? Well, previously we smushed these two masses together, right? We smushed them together into one. If we're looking for the tension in this rope, we have to unsmush, right? We have to go back to the original problem. So you can find what that tension is by either focusing on, you can either focus on the 3 kilogram mass. Does the 3 kilogram mass have that tension on him? Yeah. Or you can focus on the 4 kilogram mass. Either mass will lead you to that tension, right? So which one should we do?
3.
The 3. Let's do the 3. But just so you know, you could also get the tension by focusing on the 4. Right? So looking at the 3 kilogram mass, what are the forces on the 3 kilogram mass? You got mg down, where that m is the 3 kilogram, right? That m right there. So what's that going to be? 3 times 9.8. So this is 29.4. Well, that's for me. Hold on, pause this. mg's 29.4. All right, what's the force up on this green 3 kilogram bucket? T2. So now look, there's the free body diagram for this guy, right? So you sum the forces. Remember, down is plus. Why is that important? Because that's the direction of the acceleration. So you got to go 29.4 minus T2 equals MA, where this M is what? 3. So now you can solve this for T2. Just do the algebra and you'll get 24.5 newtons. Now look, just real quick, you also could have gotten T2 from this guy right here. You could have gone, all right, here's that dude. Now what are the forces on that dude? Well, what's holding him up? T1, which by the way, we know T1 from earlier. We know T1. It's 57.2. We got it. Okay, now what's pulling this dude down? T2 and mg. Where that mg, so what's 4 times 9.8? That's 39.2. This mg right here is 39.2. Okay, so now watch. Sum the forces for that guy. You're going to get, so remember, down is plus, up is minus. So you're going to get T2 minus 39.2, plus, sorry. Both of those are plus. Who said that? Nice. That's plus. And then minus T1 equals MA, where this M is what? 4. This is the 4 kilogram guy. Now solve this for T2. Guess what you're going to get? 24.5. And remember, T1 we know. T1 is 57.2. All right. Done.